Alright, hi everyone, welcome back to the channel. In this video, we are going to be discussing this problem, edit distance, which is the 10th problem from the CSES problem set. Let me remind you that this video is a part of a dynamic programming series, which is running on this channel. So if this is the very first video from which you're starting this series, I would recommend you to first of all check out the very first video where we've actually looked at, the concepts and a general mindset to approach all of these problems. So let's first of all read the problem statement. It is written that the edit distance between two strings is the minimum number of operations required to transform one string into the other. Okay. The allowed operations are add one character to any of these strings, remove one character from any of these strings, or replace one character in any of the strings. Okay. First of all, let's look at the constraints. The constraints are very important here. It's given that n is going up till 5000 and m is going up till 5000. N and m are both lengths of the strings, right? So this clearly tells us that, some sort of solution like n into m might also work, right? So this is one idea or one hint that you should get from constraints whenever you're solving DP problems, right? Right, so let's try to understand what exactly is happening here. Let's consider the same example first, love and movie. Now, if you look at these two strings, let's start from the last character. Look at this E. This E is matching here, so we will not do anything, right? Then you have V and then you have an I here. Now, what you could do is that, let's suppose in love, you could change this V to an I. This is one possibility, right? That let's suppose you go from love to LOIE and you keep movie as the same, right? In this case, what will happen now? Now the second last character is also same. So let's suppose remove it. Okay. Now let's suppose you look at LO and you look at MOV, right? Now you could, let's suppose, remove this V from MOV, right? You could, let's suppose, remove this. Then you are left with LOIE and MOIE, right? So we've already made two changes. Remember, the first change that we made was that we converted this V to an I. The second change that we made was that we removed this V from MOVIE, right? Now we are left with these two strings LOIE and MOIE. What you could do now is that you could change this L to an M, right? So this would become MOIE and MOIE, correct? So now both of these strings are matching. But how many changes did we make here? We made 3 changes. What we want to do is that we want to make minimum number of changes to make both of these strings equal, right? So as it was written in the example itself, what you could do is that, let's suppose, you could change this L to an M, right? So this would get transformed to MOVE and you have MOVIE. And then you could add an I here, right? So this would get transformed to MOVIE and MOVIE. Now, in this case, if you look at it, we've made just 2 changes and we've been able to make both the strings equal, right? So that is exactly what we want to do. We want to make both the strings equal by making minimum number of changes. Okay, so let's try to consider an example here. Let's suppose you had something like TLEA and you had TLE, right? What are the things that you could do? Let's start from the last character. Let's look at this A and let's look at this E. Clearly, they're not matching. Yes. So what we could do is that, let's suppose we remove A. Okay, if we remove A, what will we be left with? We will be left with TLE and TLE. Yes. Another thing that you could do is that you could remove E from the lower string. So then you would be left with, if you remove E from the lower string, you would be left with TLEA and TL. Yes. Another thing that you could do is that you could probably replace A with an E. Replace A with E. In this case, what you will get? You will get TLEE and you will get TLE. Yes. Or what you could do? You could probably add a character in the second string, right? So one more thing that you could do is that, let's suppose you add A to second string. In this case, what you will get? You will get TLEA and TLEA. Yes. So essentially, if you just look at the last character from the first string and the second string, there are so many possibilities that are out there, right? You could do so much with it. And you don't really know which of them is going to give you the optimal answer. Because right now you're just looking at one character. You don't know the string before that character, correct? So let's try to make certain more observations. Let's say if you had TLEA and if you had TLE, okay? There are 2 things which will actually result in both of the strings being kind of equal. So let's suppose we have, one is remove A. Okay, you remove A from the first string, what will you get? You will get TLE and you will get TLE. Okay, another case is where you add A to second string. Okay, in the first case, you removed A from the first string and you got TLEE And in the second case, I'm saying add A to the second string. So you will get TLEA and TLEA. Okay, now try to understand both of these cases here. Okay, if I look at the last character now here, both of these last characters are matching, correct? So can I say it is okay to discard these two last characters? Because they're both matching, right? Now going forward, I will not need this last character to be matched again. So what I can say is I can just remove this, correct? Now what you will understand from this point is that adding a character to the second string or removing a character from the first string are kind of the same things. See, in both of these cases, we ended up with TLE and TLE. We ended up with TLEA in the second case, but we clearly know that the last characters are going to match. We know this because we've added the same character from the first string to the second string, right? Let's suppose you had something like TLEAP, okay? And you had something like, let's suppose MLEA, okay? Now look at it. This is the first string TLEAP and the second string is MLEA. Now what can you do with the last character? You know for a fact that these last characters are not matching, okay? What you could do is probably, let's suppose, add P to the end here. Yes, if you add P to the end here, you will be left with this part of the string, TLEA and MLEA. Yes or no? Because this P is matching with this P. Secondly, what you could have done is that, let's suppose you remove this P entirely from the picture. In this case also, you're left with the string TLEA and MLEA. Yes? Okay. Okay, let's consider one more example. Let's suppose you had something like Priyansh. And let's suppose you had something like Riyansh. Look at these last two characters. They're both matching, correct? So if both of these characters are matching, we don't really need to care about them. We can just exclude them from the string. We will just say that, okay, I want to match this part of the string with this part of the string, correct? So what does this really mean? If I have two strings of length n and m, let's suppose this is string A of length n, and there is string B of length m. First case is where you just say that, okay, the last character of first string matches with last character of second string. Now in this case, it obviously makes sense to just exclude the last character from the first string and exclude the last character from the second string, and just consider A of length n-1 and B of length m-1 and try to match them, correct? Second case is where you say that, okay, this is same thing, last character of A is not equal to last character of B. Alright, so let's consider both of these cases through an example. Let's suppose you have something like A, B, C, D, and you have something like X, Y, C, and let's suppose E. Okay, these are the two strings that are given to you. Fine. In this case, what do we know? We know for a fact that these last two characters are not matching. So we will have to somehow match them. What can you do to match them? Either you can replace this D with an E in the first string. That would result in A, B, C, E and X, Y, C, E. That is the first thing that you could do. Second thing that you could have done maybe is that instead of replacing the D with an E, you replace the E with a D. In this case, it would have resulted in A, B, C, D and X, Y, C, D. Yes, in both of these cases, what are we doing? In both of these cases, we are replacing one character. Second case was that you remove from first string. Yes, you could also remove from first string. In this case, what will happen? You will be left with A, B, C and X, Y, C, E. Correct? Or what you could have done is that instead of replacing from the first string, you could have added in the second string. Or add in second string. And I will tell you that both of these operations are same. Why are they same? Because see, in this case, you removed character D from the first string. In the second case where we are saying, okay, add the same character in the second string, this would have resulted in A, B, C, D and X, Y, C, E, D. Yes. Now look at the last two characters here. They're both matching. So can I say I can discard them? Yes, I can discard them. Even if you add the character in the second string or you remove the character from the first string, you're eventually going to end up with the same subproblem. See, you had ABC, XYCE, you have ABC, XYCE. Correct? Now what is happening in this case when you're removing one character from the first string? In this case, can I say the length of the first string is going to reduce by 1? Like if this was a length of n and if this was a length of m, in the very first case where we replaced the characters, we were left with n-1 and m-1. But in the second case, where we removed one character from the first string, we are left with n-1 and m. The length of the second string is not changing. Correct? You could also say that, okay, why are we removing the character from the first string? Why not remove the character from the second string? correct? What would that have resulted in? You initially have A, B, C, D and X, Y, C, E. If you remove from the second string, what would that result in? That would result in A, B, C, D and X, Y, C, correct? In this case, what are we doing? We are removing from second string. Now tell me one thing, isn't this the same as saying add in the first string or add in first string? If you would have added in the first string, what would that have resulted in? That would have resulted in A, B, C, D, E, because you would have added the same character E into the first string, and the second string would have been X, Y, C, E. Now clearly the last two characters match, so you would discard them and you would still be left with A, B, C, D and X, Y, C, correct? So what I mean to say here is that these two operations, either removing from the first string or adding in the second string, they're both same. So now can we think of a DP state? Yes, we could say something like DP of n comma m, or let's put it like this, DP of I comma j is equal to edit distance between first I characters of A and first j characters of B. Let's suppose the first I characters of the string A are let's suppose A, B, C, D, and the first j characters of the string B are, let's suppose, A, B, X, Y, C, D and E. Okay, let's suppose these are the first I characters and these are the first j characters of string B. Got it? I have three things that I can do. Either I can replace this D with an E or replace E with a D. That is the first case. In this case, what would happen to the string? If I replace this D with an E, or if I replace this E with a D, this would result in A, B, C, E and A, B, X, Y, C, D, E. Correct? In this case, what is happening? The last character is now matching because you have clearly replaced. If the last character matches, what is the length of the string that remains in the first string and in the second string? In the first string, can I say I minus 1 characters are remaining? And in the second string, can I say j minus 1 characters are remaining? Correct? Similarly, you could have replaced this E with a D. Instead of replacing in the first string, you could have replaced in the second string. That would have resulted in A, B, C, D and A, B, X, Y, C, D, D. In this case also the last character is going to match. So can I say still in this case also I minus 1 characters are remaining and j minus 1 characters are remaining? Correct? So what this really means is that if the last character of A is not equal to the last character of B, I could transition into something like DP of I minus 1 and j minus 1 with just one operation. Correct? What is that one operation? That operation is replacing the character in any of these two strings. Correct? That is one thing that we're doing. Second thing that we could have done is that we could have removed the character from first string, right? So this was a case where we replaced. Okay. And what is a string? Our given string was A, B, C, D and A, B, X, Y. Correct. Second case that we saw was that we could remove the character from the first string. If you remove the character from the first string, what would happen? This would result in A, B, C and A, B, X, Y, C, E. How many characters are remaining here? In this first string, I minus 1 characters are remaining, and in the second string, still j characters are remaining. Correct? This other thing that you could do is that instead of removing from the first string, you could remove from the second string. Correct? That would result in A, B, C, D and A, B, X, Y, C. How many characters are remaining in the first string? Still I characters are remaining. How many characters are remaining in the second string? J minus 1 characters are remaining. Yes, what is happening here? In all of these cases, we are doing one operation. In this one operation, we are saying replace. In this one operation, we are saying remove from first string. In this one operation, we are saying remove from second string. Correct? So we clearly know how we can transition now, right? Now what happens if, let's suppose, the last character of string A matches with the last character of string B? Let's suppose you have A, B, C, D and you have X, Y, Z and D. Can I say if the last character is already matching, just discard it, don't care about it, and reduce the length of this by 1 and reduce the length of this by 1? Correct? So we clearly know what are all the possibilities that this could result in. If you have DP of ij being equal to the edit distance between first I characters of A and the first j characters of B, you have smaller subproblems into which this breaks. Correct? So can I write my transition like this? That okay, if A of I minus 1, see, now we are considering zero based indexing here. We are saying first I characters of A and first j characters of B. If a of I minus 1 equals to b of j minus 1. What happens in this case? In this case, I can simply say dp of ij is nothing but equal to dp of I minus 1 comma j minus 1, right? Because we're just saying that, okay, remove these characters. Remove the ith character from A, remove the jth character from B. Consider strings of smaller lengths. But what happens if they're both not equal? If they're both not equal, we are saying that there are three possibilities. First is the case where you replace. If you replace both, the length of the first string reduces by 1 and the length of the second string reduces by 1, but you have used one operation. So can I say in this case you have dp of ij being equal to dp of I minus 1 j minus 1 plus 1. Why am I writing plus 1? Because you've used one operation. Second case is where you remove from first string. If you remove from first string, it clearly means that you've removed one character from the first string. So your dp of ij is going to be equal to dp of I minus 1 comma j. Remember, we are not changing anything in the second string. Plus 1. Why plus 1? Because we are using one operation here. Similarly, the third operation is where you remove from the second string. Yes. In this case, we'll simply write dp of ij is equal to dp of I comma j minus 1 plus 1. Yes. So what would you do? If you have three types of operations that you can do, you would just take the minimum of them, right? You want the minimum number of operations to convert one string into the other, and you have three possibilities on a particular character. You would just take the minimum of them. Correct? So now, what is going to be the base case here? Like, where is this thing going to end? For example, if your first string was something like a, b, c, and your second string was x, y, z. Let's suppose you removed from the first string, it resulted in a, b, and x, y, z. Let's suppose you removed from the first string again and it resulted in a and x, y, z. And let's suppose you removed from the first string again and it resulted in an empty string and x, y, z. What would happen when one of the strings become empty? When one of the strings become empty, it clearly means that you would have to remove all the characters from the other string. So can I say something like dp of I comma 0, which means that I characters are remaining in the first string but 0 characters are remaining in the second string, is nothing but equal to I. Because you will have to perform all these I operations to remove I characters from the first string. Similarly, dp of 0 comma I, when you have I characters remaining in the second string but 0 characters remaining in the first string, in this case also it is equal to I. Right? And if you were to combine both of these cases, it clearly means that dp of 0 comma 0 is also equal to 0. When both of the strings are exhausted, then yes, dp of 0 comma 0 is 0. What is going to be the final subproblem? Look at the state. How have we defined it? We have said that dp of I comma j is the edit distance between first I characters of A and first j characters of B. How many characters of A are given to us initially? N characters. How many characters of B are given to us initially? M characters. So can I say final subproblem will be dp of n comma m? Correct? So this is the main idea behind this problem. If you were to talk about time complexity, it's pretty easy. Time complexity is just nothing but number of states multiplied by average transition time, right? Now here the states are simply order of n into m, right? So number of states are order of n into m. And what is the average transition time? Can I say average transition time is just order of 1? Because these are the cases that you're just considering. What about the space complexity? The space complexity again is the number of states. So space complexity is going to come out to be order of n into m, because the number of states are here order of n into m. Got it? Now one more thing that you must understand is that there is a scope of space optimization here, right? We've already understood what is space optimization. In case you haven't checked out that lecture, I would highly recommend you to do that. Now we already know what is space optimization. If you're talking about this dp of I comma j, what are the states it depends on? It first of all depends on dp of I minus 1 j minus 1, this state. Let me write this as an orange state. It depends on this orange state because this is dp of I minus 1 comma j, and it depends on this orange state, which is dp of I comma j minus 1. Can I say one thing, that in order to get the answers for a particular row, it depends on the answers of that particular row and the answers of just the row above it. So I don't need the answers of any other rows while calculating the answer for my current row. I just need the previous row. So what we're doing first of all here is that this n is the length of the first string, m is the length of the second string. Fine. Then we're defining our dp states here. We are saying dp of I comma j is the minimum steps to match the first I characters of first string with the first j characters of second string, which is the same as saying edit distance between the first I characters of first string and the first j characters of the second string, right? This is the base case that we've defined, that dp of I comma 0 is equal to I, because we have exhausted the second string, but there are I characters remaining in the first string. Similarly, DP of 0, j is equal to j. What this means is that the first string has exhausted while the second string has j characters remaining. Correct? Now it's pretty simple. You have DP of ij being dependent on DP of I minus 1, j minus 1, I minus 1, j, and I comma j minus 1. So essentially, I has to iterate from 1 to n because your current state is dependent on previous states. Similarly, j has to iterate from 1 to m because your current state is dependent on previous states, right? So this is the order of the for loops here. Next, what I'm doing is I'm just extracting these two characters, the last character of A and the last character of B. Not exactly the last character, but the ith character of A and the jth character of B. Okay. Then I'm saying that, okay, if they both are equal, then I can simply say DP of ij is equal to DP of I minus 1, j minus 1. What this means is that you discard the last ith character and the last jth character, right? If they're not equal, can I say, in order to replace, it would require one operation. So this is the case where we're replacing, right? So this is the second case where we said that, okay, you can remove the ith character from the first string. In this case, you have DP of I minus 1j and you added a plus 1 because you've taken one operation. Similarly, this is the case where you removed the jth character of string B and you added one operation for that. Okay. And finally, you just printed DP of n comma m as the final subproblem. So that is the main idea behind this problem and the main code. Alright, so in case you understood everything that was taught in this video, don't forget to comment understood on this video and don't forget to subscribe and press the bell icon to not miss any future updates on the series.